Wanted to go through an example in using Excel to find a confidence interval, specifically for t-distributions. So I have an example problem here. It's asking us to either use the normal distribution or the t-distribution. We'll see that this ends up being a t-distribution problem. We're going to want to find a 99% confidence interval, and then we're going to interpret those results. So we are given that there was a random sample of 50 people, and they were measuring BMI. The mean BMI for those 50 people, so for the sample, was 28.2, and the standard deviation was 6.08. So first, let's verify why this is a t-distribution. So for condition number one, for checking the distributions, we need to make sure this was a random sample. That's just that they told us it's a random sample, and we don't have any other way to verify that. If that wasn't true, it'd be hard to continue. So now we need to make sure that the population is normally distributed, or the sample size is at least 30. The sample size here is more than 30, it's 50, so we can use either the z or the t distribution. So the question is then, we're going to be able to do this problem, but is it a z or a t distribution? And that all relies on sigma, the population standard deviation. So kind of most of these answers here, the last choice is the population standard deviation known or unknown? If it's unknown, then you would have sample standard deviation. So the question, is this standard deviation given, 6.08, for the entire population or for just the 50 people? And based on the structure there, it sounds like that standard deviation is only from those 50 people. And so we do not know the population standard deviation. It is unknown. We only know the sample standard deviation. You want to be careful. You always have to know a standard deviation. It's which one is it? So let's double check if this is right. We want to use a t-distribution because the sample is random. Yes. The population is normal. No, that's not the right one. So then it's answer choice D here. We want to use a t-distribution because the sample is random. Yes. The sample size is at least 30. Yes. And the population standard deviation isn't known. Okay, so we're good to go. So now we want to find the confidence interval. We are going to be able to find it because we met the three conditions for the confidence interval. So first, from the problem, we need to find all the information they give us, which will always have to be given. So the sample mean, this was the mean for the BMI, 28.2. The standard deviation is given as 6.08. This is S, the sample standard deviation. The sample size was 50, and we want to find a 99% confidence interval. So our confidence level is 99%, and we'll write that as a decimal 0.99. So alpha is the opposite of the confidence level, so the complement probability to that, how much is outside of it. So 1 minus the confidence level. And then how much is in each tail will be half of that, so alpha over 2. And that'll let us find the critical value. Right? We need the critical value to find the margin of error. The margin of error is going to be the t critical value times the standard deviation divided by the square root of n. So the critical value, 0.005, is how much is in each tail. And we'll find the left-looking tail first. So it's going to be a t dot inverse The probability is how much is in that tail, and the degrees of freedom is the sample size minus 1, or 49 in this case. That gave us a negative value since we found the left critical value, so maybe we'll adjust that to be a positive 1, so we can multiply that by negative 1. Alright, it's a little overly accurate. Let's also get rid of some of those decimals. Alright, the margin of error, we are ready to calculate that now. So that is the critical value times the standard deviation divided by the square root of the sample size. And the sample size was 50. Let's fix that. Standard deviation. Right, so our margin of error is 2.3, so it's going to be the width of the confidence interval from the middle. And we're ready to find the confidence interval now. The lower limit of the interval is going to be our sample mean minus the margin of error. And our upper limit is going to be the sample mean plus the margin of error. So in the sample conducted, the mean body mass index was 28.2, which is our best individual estimate for what the population is. But if we want to give a ranged estimate, an interval estimate, we can be 99% confident that the population BMI is between 25.9 and 30.5. Right, this is already rounded to 2 decimal places, so we're good to go. So the smaller value first, this is in interval notation, so 25.9, and the larger value, 30.5. Alright, let's hope that works. Good. Alright, lastly, the interpretation, which we kind of just said. So the population BMI is in this interval, from 25.9 to 30.5. And we have the wording with confidence. So with 99% confidence, the population BMI is between the bounds of the interval, which are the numbers we just mentioned. So this is our popular phrasing for the interpretation. All right, looks good.